Welcome, I'm Mrs. C, and this is Math to Find. Today we're going to factor the GCF from algebraic expressions. I'm going to show you two different methods to factor out the GCF, or greatest common factor, in expressions. The first method I'm going to use is a more traditional method, where you find the GCF of the terms first and then use division to factor the expression. We'll begin by finding all the factors for the coefficient 21. We know 1 times 21 is 21, and 3 times 7 is 21. We'll do the same for the coefficient 49. 1 times 49 is 49, and 7 times 7 is 49. Now we need to look for the greatest common shared factor between them, and we see that it is 7. The next step is to divide each term in the expression by this GCF of 7. And 21m divided by 7 is 3m, and negative 49n divided by 7 is negative 7n. The last step is to rewrite the expression as the product of the GCF. To do this, we'll place parentheses around 3m minus 7m, because remember, parentheses mean multiplication. And then we place the GCF, which is 7, on the outside of them. And there you have it. 7 times the quantity, 3m minus 7n, is the factored expression of 21m minus 49m. Let's factor this same expression again using a different method called the ladder method. First, I'll place the expression into this ladder, which looks like an upside-down long division sign. Now I'm ready to start factoring. Looking at the coefficients 21 and negative 49, I see that they share a common factor of 7. So I place this 7 on the outside of the ladder. Next, we divide each term by this shared factor of 7, just like we did using the traditional method. 21m divided by 7 is 3m, and negative 49n divided by 7 is negative 7n. Now looking at 3m minus 7n, we see that they do not share any other factors, so we are done factoring. We'll bring down 3m minus 7n, place parentheses around them, and place the GCF, which is 7, on the outside, and we're done. The latter method eliminates the first step of the traditional method of finding the GCF first before dividing. But let's look at some expressions where the GCF is not so obvious. This is when the latter method is more efficient than the traditional method. Let's start with the expression on the left, 32y plus 48. First, we'll place it in the ladder, then look for any common or shared factor. It doesn't have to be the greatest common factor, just any shared factor. I'll choose 4. Then I'll divide each term in the ladder by 4. 32y divided by 4 is 8y, and 48 divided by 4 is 12. Next, I see that these terms share an additional factor, so I'll need another ladder. And the shared factor I see is another 4. 8y divided by 4 is 2y, and 12 divided by 4 is 3. Now we are left with these two terms that do not share any common factors, so we are done with the ladder. We'll bring down the 2y plus 3 and place parentheses around them. The last step is to find the GCF for these terms by multiplying the two shared factors. And 4 times 4 is 16. So 16 is the GCF. We'll place it outside of the parentheses. And that's it. The factored expression is 16 times the quantity, 2y plus 3. Now let's simplify the expression 14x minus 28y. Since the two terms share a common factor, we need a ladder. Next, I will choose a shared factor, and I know that 2 will divide evenly into both of these. Now we'll divide 14x by 2, resulting in 7x, and negative 28y divided by 2 is negative 14y. I see that these two terms share another factor, so we need to repeat the process again. This time, I see that they share a 7. And 7x divided by 7 is just x, and negative 14y divided by 7 is negative 2y. We're done factoring now because x and negative 2y do not share any common factors. So we'll bring it down and place the parentheses around them. Next, we need to find the GCF by multiplying the shared factors, and 2 times 7 is 14. The last step is to place this GCF of 14 outside the parentheses, and we're done. Thanks for watching, and I hope these examples helped you out. And until next time, keep math awesome.